Okay, time for a recording that gives you some more conversation and practice about naming aldehydes and ketones for those who'd like it. Sometimes they're not as bad as we fear, so let's give it a whirl and see where it goes. IUPAC names are the ones we like to focus on because they're the ones you need to use to look up something in a reference book, such as a physician's desk reference or some other catalog that would give you the hazards and things. So let's work on understanding that approach. All right, several examples shown here. The first one, the letter A, if you count, has 1, 2, 3, 4, 5 carbons with the CH and double bond O on the end. That would be an aldehyde. The prefix for 5 carbons is always pent, and the ending for an aldehyde is ANAL. We don't have to specify the number here because aldehydes are always on carbon 1. And sometimes you'll see this as CHO in a condensed form that tells you it's an aldehyde. All right, let's look at another. How about B? Well, this time we have the C double bond O in the middle. And again, if you're counting carefully, you should see 4, 5 total carbons. And when the C double bond O is in the middle, we call that a ketone between 2 carbons. And with 5 carbons, the same prefix applies, so it's pent. And then the ending is ANONE, oops, pentanone. Now, when we're having that type of structure, is there a number required? And I raise the question because, yes, there is. Could you have the carbonyl of the ketone in more than one place? You could. And so that needs to be specified. This would be 3-pentanone. It is on the 3rd carbon. Compound C. Longest chain is the usual game. So start with the carbon that has the carbonyl. Whoops, sorry. 2, 3, 4, 5, 6. And on carbon 4, we have an extra group to name. It's the methyl group. So if there's 6 carbons, the root name is called HEX, like hexane, except for now, instead of hexane, it's hexanal, because it's an aldehyde. And we have to specify the number. Still, no, you don't have to, because aldehydes are always carbon 1 in these structures. And then you have to specify the location of the methyl group, which is on carbon 4. So 4-methyl hexanal. That should be all one word, but I don't always guess the spacing correctly. Compound D. First question is, what's the functional group? Is it an aldehyde or is it a ketone? Well, the ones that have aldehyde are going to have this C double bond O with a hydrogen on the end of the chain. This one's not. So this one is also a ketone. And then the longest continuous carbon chain is simply 4 across here. And so 4 carbons would be butanone. And again, do we have to specify the number to tell us where it is? Well, if you think about it, no. It has to be on a non-end carbon, and there's 2 of them, and they'd be carbon 2 regardless of how you chose to number it. So it would be 2 if you wanted to put a number in there, but it really doesn't tell us anything by including it. Now, the last one here, we're being posed the challenge to draw something given its name. Oh yes, cyclostructures always make us think. So let's look at what would cyclohexanone be. So let's make a cyclohexa, well, it's like cyclohexane. And if it's anone, that must be a ketone. And with the ketone, you just put it on any carbon because in this case, it doesn't honestly matter because they're all alike until we've added more to the structure. So that's fine. And then we have to decide where 4-ethyl should belong. Since the last name of the compound is hexanone, cyclohexanone, and the ketone therefore would be carbon number 1. And so if you want to put the other group on carbon 4, then count around whether you go to the top or the bottom, it doesn't matter. This side will become carbon 4, and that would become 4-ethyl. Oh, but we have to put ethyl, not just 1. So CH3, CH2. I should have just written carbons without writing in the hydrogens, but that's okay too. Hopefully that one makes sense. All right, let's try another one. There's some more compounds to name. Well, top one, think about it. Not too bad. This one has how many carbons? 1, 2, 3, 4, 5, 6. And this is, again, a ketone. Easy enough, then it should be hexanone. Do we have to specify where the carbonyl of the ketone is? Yes, because it could be on carbon 2, could be carbon 3. In this case, it's on carbon 3. Could it be on carbon 4? Not really, because that's the same as carbon 3. All right, structure B at the bottom. Aldehyde or ketone is the first question. Well, there's your carbonyl. It's on the end. That makes it an aldehyde. And you always got to pay attention to functional groups. It helps. And I constantly have that reminder. I hope you've caught it by now. Find your longest chain. Usual game. 1, 2, 3, 4. Does it matter if you go up or down? Nope, comes out the same. And then on carbon 4 is some other group here. Well, I guess that would be probably methyl. So if it's 5 carbon longest chain, it would be pentanal. And the carbon number 4 has a methyl group on it. 4-methyl pentanal. Fair enough. Structure C, we don't always like ball and stick drawings, but if you want to redraw them, you can. Sometimes that helps. In this case, I don't think it's awful. They're drawn out, or at least viewable, at least from this representation. Your longest carbon chain, in my opinion, looks like we go more or less straight across. They didn't make this one too odd. Looks like 6 carbons, so HEX, hexa. Well, is it aldehyde or ketone? In this case, it's a ketone. And so hexanone would be our name. We have to specify where that carbonyl is, and similar to the one at the top of this page. So that would be 3-hexanone, because you're going to make the lowest number for the ketone. You could have started from the other end, but then you would have had 1, 2, 3, 4 for your ketone, and that's not the lowest number. The lowest number goes to the group that gives you the ending. The other piece to name in this compound is on carbon 5. Nothing exciting. It's just 5-methyl. Not too bad. Okay, a couple more comments about compounds and names for aldehydes and ketones. We're not going to get into the worst of them, but we can look at some interesting challenges. The thing to know is that aromatic compounds, the simplest of the aromatic aldehydes, is going to be given the root name benzaldehyde. You can draw it with one of these structures, or if you remember that my preference is not to show anything that makes you think of double bonds, put it in with a circle. That's benzaldehyde too. And this one is pleasant smelling, like almond extract. And any other derivative of that will have benzaldehyde as its name, and you'll locate and identify substituents. Other thing to notice is that there are sometimes common names for ketones. They're a little bit funny because they're really not IUPAC, but they don't count up the number of carbons the way you expect them to. And so what they're going to do is they'll name the 2 groups attached to a carbonyl and then use the last name ketone. So diethyl ketone, what is that trying to suggest? So we have 2 carbons. There's one ethyl group, and then another ethyl group with a ketone between them. So you put your double bond O here. Well, in fact, that's actually the same as 3-pentanone. And so it's a non-standard, non-IUPAC way of naming something, but at least if you think about it as 2 ethyls, that means 2 times 2 carbons plus 1 more carbon is a total of 5. It's you can make sense of it, but you probably wouldn't really prefer that. One more conversation about names. Here's a compound that's interesting. Sorry for the interruption. I had to put a new battery in for the microphone. So when you put all the names together, you have to name the last fragment here. And an alcohol as a substituent is not always something we remember, but it's called an hydroxy group. And so if you put that all into one long name, the last name is benzaldehyde. The numbers go with each substituent, and then it's going to be alphabetical order. So 4-hydroxy, 3-methoxy, benzaldehyde. Now, you know what vanillin is. Okay, probably that's not going to be something you need to look up very often, but it's kind of fun to be able to apply these things. I hope that helps you. Good luck on your assignments and your studying. Ask lots of questions, and I'll see you in class.